All right, welcome. Hey everybody, how's it going? Happy Saturday to everybody. Apologies for the weird schedule today. I know Stoffelberg was going to stream at 1 o'clock, which is kind of my usual time, so I hung out there for a while, but I intended to either stream possibly tomorrow or a little bit later today, so we're doing later today. So I got inspired. We found a bug in the IP address package we were using. Actually, some code I wrote as far as masking off an IP address with a prefix and creating a prefix out of that, so we're going to fix that. So it's one of those things where you write some code and you realize, like, how did this ever work? Yeah, so at the moment the tests pass, but I think that we've discovered there are some weird edge cases. So we had a conversation in the networking channel in Gopher's Slack, and beforehand... Yes, bitwise operations. Yeah, so beforehand the code looks something like this. So if I run the tests right now... So a lot of the existing cases we had passed just fine, but I noticed yesterday when I was working on CoreRAD that if you do the IPv6 address 00 and then like a mask of /63, so something that's not divisible by 8, it would produce this weird prefix right here, so this 000FE63. Really makes no sense, right? What we actually want is : /63. So I thought an easy fix would be, okay, excuse me. I thought an easy fix would be that if we just added a conditional here, this appears to make the test pass, but I think we've still got some problems here. So Dave Anderson, D. Anderson on the internet, is working on a potential better fix for this. I think in the meantime, we're going to write some benchmarks and then see where Dave is at. I'm not sure if he's in the Twitch chat right now. If he is, I'd be curious to hear what he finds. But he mentioned in the networking channel, let's see here. Oh, you are? Oh, 1is42. Nice. Welcome. Good to have you here. Let's see here. So all the tests run on an input. Excellent. Great. So Dave mentions that I see why the test didn't catch this. All the tests run on an input IP of all ones. So the incorrect masking does the right thing accidentally, which pretty much I think sums up the way that I do bit operations. I'm not particularly good at them. So I also noticed earlier I had an operation here, so I was doing... Oh, you do have a pull request. Nice. One sec. I'll pull that up. Sweet. Contains only tests that fail right now, working on the code fix. Awesome, awesome, awesome. Let's look at this. Okay, so this is the case I added. So basically we want to test for : /63. In addition here, we have an optional zone identifier. So this library can handle v4, v6, and also v6 with zone. So for example, with link local addresses, you need to specify the zone identifier as well. So the test case is exactly the same, but okay, so here's something that fails. So partially masking one byte that contains both ones and zeros on either side of the mask limit. I see. Okay. So this is tricky. Right. Okay, so Dave mentions in the chats, last test is the key one that fails, returns 100.192.00/10 instead of 164.00/10. Yes, because that would be the CGNAT range, right, is 164/10. It'd probably be good to come up with an IPv6 equivalent as well, but that being said, the logic is address family agnostic, so it's probably okay as well. So I will go ahead and close my other PR because clearly what I was doing is not right. So this will be superseded by number 41. Yeah, let's see here. CGNAT range is so abused now. Yeah, maybe. I mean, so for example here, the use case for the CGNAT range is Dave works for Tailscale, and they are doing lots of very cool things with WireGuard, basically easy mesh WireGuard setup. So I don't know exactly if they are abusing the CGNAT range, but that's what they're using right now. So, right, okay, so Dave mentions that 100.64/00/10 is the CGNAT range, which happens to be a well-known prefix that's not on byte boundaries. And oh yes, we are abusing the CGNAT prefix. Great. Gotta get some IPv6 ULA going on. I will generate you a ULA on stream right now for Tailscale. Nice little cold brew coffee. Right, I was gonna close this because number 41 will supersede it. This isn't a sufficient fix. Close. And delete the branch. Cool, okay. So I think Dave's working on something. So the reason I noticed this, let's take a look at this playground program. So the reason I noticed this in the first place is I was working with this : /63. Oh, okay. We still have to figure out if we're doing 1 ULA per customer or 1 ULA for all of Tailscale. I'll get back to you on how many ULAs we need. See, I feel like... I think probably a ULA per customer is the right call. I think that you would want a... Because... So ULAs are broken up in /48s. So in theory, if you allowed a customer to have multiple meshes, like a customer could have up to 65,536 mesh networks, separate like Tailscale networks, which would be good. I don't know if that's a plan or not. But otherwise, it is a huge waste of IPs, yes. But in theory, there's enough space where it shouldn't really matter. But yeah, I don't know. Anyway, so the reason I noticed this, I actually added a v4 test case as well. But I was working on CoreRAD, and I plugged in this address into the prefix logic. So :/63, this is something weird. So in CoreRAD, we have the magic syntax for :/64 that will pick up all the 64s on an interface and advertise prefixes for them. So I had a test case that put :/63 that I expected to produce an error, but instead of producing like, oh, you know, :/63 is invalid, it produced this really weird thing. So 000 FE : : like, that doesn't make any sense. Like, you're masking off bytes on all zeros already, and it's producing FE. So I started to look at this a little more closely, and I made my tentative fix for it, but clearly that's not right. So we're going to fix that. And it turns out the same problem applies to v4. So if we have 0000/15, it produces 025400. So it turns out I'm pretty bad at bit math. So it looks like Dave's got a pretty good handle on that at the moment. So I think I'm going to write benchmarks for the netaddr package because I want to... in my case, it's not that big of a deal if it's slow, but I think it's probably, be a good open source citizen thing to do, to write benchmarks, so we'll do that. But I'm going to put on some music. One sec. So the problem is I keep messing with like my volume settings and stuff for various different things, like trying to figure out what the easiest way is to change settings on my computer, like when I'm streaming. And I'm afraid I'm going to get blasted, so I have to turn everything way down and then dial it in. Okay, this is muted on the stream. Good. Okay, we're good. Anyway. I'm a little disheveled today. Should be able to convert 63 to base 2 and then just do bitwise and. Yeah, so I think in theory that would work, but I think the problem is that we have to do bitwise and over an entire sequence of bytes, right? So we can't store the IP address like the v6 addresses in like a uint 128 because Go doesn't have uint 128s. It'd be kind of nice if it did, but instead we have to iterate the byte slice. So I think that's the problem we're running into here. And I'm just not that good at bit math. It was kind of funny. For a long time, I didn't understand like bit masking at all, and I can still do it, but it always takes me a little bit to figure out. So let's write some benchmarks. I'm going to base my changes on master, I think, for now. We're going to delete this branch. PR updated passes tests. Awesome. Okay. Wasn't there an issue to add uint 128 in Go? Yes, there have been a couple of attempts. I don't know where that's been. I don't know where that's gone because I know, for example, like Rust has like a native uint 128 type, but... Oh, hey, Flo. Oh, awesome. So as a JavaScript developer who really wants to learn low-level network programming, welcome. You're in the right place. Do you have any resource recommendations? I actually created a command now, I believe, with some stuff that I have found and other folks have, so networking. There we go. So the first couple of those are websites and the last couple are books, so we can potentially expand this list, but I think those links should give you a pretty good idea of some of the basics. In particular, I should add some descriptions. Whew, excuse me. My stomach is not quite settled. So for Beach's Guide to Network Programming, that is a great guide. It is about BSD sockets in C, but a lot of the concepts apply to Go as well, and it will teach you how things work under the hood, so it's pretty useful. The TCP IP guide seems to be pretty comprehensive. Oh yeah, no problem. Happy to help out. So it's kind of funny because I asked about this in the Gophers Slack networking channel, which is a great place. You should definitely join that. I asked about this because I learned a lot of networking stuff on my own, like just kind of my own curiosity, Okay, so that's something else to go through next. So the Beaches Guide, I assume. Can't decide if I want to do that first or some Bpf Deep Dive. Yes, Bpf is extremely cool. I know Brendan Gregg has a new book. I actually think it's on my Amazon wish list, but let's see here. Brendan Greg, BPF book. BPF performance tools. I really want this. That's the exact book. Yep. So that is this book. I really want a copy of this. I think that'd be awesome. Get it, get it, get it, says Flo. Okay, I should. It's in Safari. Oh, really? Okay. I think I have access to Safari. So, you see, my problem is that I have all these things I want to read, but I have a hard time motivating myself to actually read, which is a shame. I think it's something I need to work on, you know? What? Oh, boy. Sorry, getting some notifications. One sec. Let me check a message. Okay. Twitter? People tweeting at me? Yeah, a little bit. Okay. My Safari Queue backlog is at 52 books. Yeah. See, the problem is I have a backlog of like, I don't know, 14 or 15 physical books like sitting on my bookshelf I need to work through. It's a good start for networking with XDP. Nice. You know, I wonder, I just got new NICs. I wonder if they're capable of XDP. Actually, my 10 gig NICs from Intel. Super cool stuff. Don't know how much I'd actually use it in real life though. Yeah, that's the problem, right? Is in general you're not diagnosing issues to that level. I think it would be useful though, you know, because like TCP dump can do an awful lot. For example, things like TCP dump, MTR, etc. Oh yeah, I wanted to show you all a super cool tool actually. So let me see. Where do I have that installed on this computer? Bandwidth. I do. Yeah, check this out. So this is a program called Bandwidth. It is like a Rust bandwidth monitor thing. It is extremely cool. It shows you like the programs that are currently utilizing your network connection, which sites you're connecting to. So for example, we got the Twitch stream going on here. Yeah, very cool stuff. So I have this on my router as well. As far as I know, there's only one specialized vendor that supports XTP offload to hardware at the moment. They made a BPF engine that runs directly on the chip. Yeah, you know, I've heard of folks who, I know there were companies that were actually embedding like Open vSwitch in NICs, which is totally crazy. Oh, so you suspect buffering problems, but you have no way to prove it. Oh, you wish you had some BPF chops. It would have come in handy trying to troubleshoot some host NIC stuff. Yeah, totally. Not many NICs that support XTP. Intel provides a few. Okay, probably not my NICs from like 2012. You think for Intel, XDP still runs in the CPU. Gotcha. Gotcha. Yeah, so Bandwidth is a super cool tool. You shall install this. I like it. I run it on my router as well. I might have a really old copy here. I'm not sure. Anyway, I'm going to stop what I was doing here. We're going to write benchmarks because I don't know how to fix this problem myself. Or I did it wrong. So git stash master. Oh, really? So Packet provides VPNs with XDP support. Really? I actually started work on an AF XDP package, but I actually don't have enough knowledge to figure out how to use it. I know there are lots of folks. I know there are lots of like really cool things you can do with like AF XDP for, you know, C, and I wanted to do it in Go, but frankly, I just don't have the knowledge to like port that code. So let's do some benchmarks. Yeah, Packet is very cool. I've got a lot of, I've got some former coworkers that work there now. It seems like a very cool place. Do we have benchmarks in here? We do, okay. Yeah, some of the people I worked with at DigitalOcean are there. Yep. So Dave, I think it's probably reasonable to do a benchmark for both v4 and v6, but we don't necessarily need different addresses. We just want, well, IPv4 contains v6. Gotcha. I'll probably do like a table-driven benchmark. Not table-driven test, table-driven benchmark. So, and we'll do a prefix of... hey, hello. Nice gopher emote. Funk Dev, thank you so much for the follow. Probably want to exercise both code paths since they use different impls on the inside. Yes. v4, v6, v6 plus zone. Excellent, I can do that. Yes, we actually do have more emotes available for tier 1 now. So MD layer, we have the error, we have the gopher, and we have the tux. So if you are a subscriber, you could spam these emotes in chat. Pretty cool, huh? I'm gonna, as soon as we get more subs or emote slots, I'm going to make one that is the no else. Just like the else with the crossed out red text or something. Because we joked about that. Right, so they should not perform the same except from some linear scaling of more bits. Right, that's kind of what I figured as well. But yes, it is good to verify, for sure. And I'm all over the place today. Okay, func benchmark. Let's see, so IP prefix. This is kind of a strange convention, though, because this is actually the IP prefix method and not the IP prefix type. I'll call it IP prefix masking, perhaps, for clarity. And I actually have I've got an alias here for, or a snippet for creating table-driven benchmarks, but... So for each test we run, these are sub-benchmarks. Yes, you do need to go jump into networking in the Gopher Slack. It is a great channel. Lots of really, really knowledgeable folks. This is where I... Oh, okay, so you posted... Let me go check the PR really quick. Yeah, lots of awesome folks in the Gopher Slack for sure. Oh, okay, so this is fixed now, huh, Dave? Okay. Did you add your CGNAT? You did. Okay, excellent. Perfect. So skip over all bytes for not masking at all. Yep, makes sense to me. Ooh, else statement? I'm kidding, it's fine. We have a joke on stream where I will eliminate else statements with extreme prejudice. But I think in this case it might actually be... I don't know, I wonder if it would be more efficient. It doesn't really matter. We'll worry about benchmarks. 0 is the lower 8 minus m bytes. Byte. Yeah. Seems good to me. So this is the v6. No, static check does not complain about the else. So static check would complain if there were a return case in both of these, in which case I would agree with static check. But I think here this is actually fine. I think my grievance with else is more so when you have like a really long block with an else at the bottom. Actually, there's one place in my code where I know I'm doing this badly. We should fix that. Maybe we will. /4/4. Okay. /63, this is my original case, and then we have the CGNAT range as well, so we cover v4, v6, and then with zone, optional zone. So yeah, looks good to me. Thank you so much, Dave. I appreciate it. This is going to help fix a problem in my own code, so I appreciate that. I go back and forth. For readability, I use if else exclusively when they specifically do one or the other versus early exit. Yeah, I see what you mean. We don't think that every if else has to be an early return. Yes. In this case, it's a loop where we go over every byte, and for every byte we do exactly one of two things. So I think it's more. So I think else is more readable. Yeah, I think I'd agree with that. That's fine. Yeah, I think that the point about having really long blocks with else is what usually gets to me. But I can show an example in my own code where I break my own rules. So, yeah, this looks good. I'm happy to merge this, or I guess I'll let you merge it. I'm not a performance nerd in Go, so the generated code might be terrible. I don't know. Yeah, me either. I'm the wrong person to ask. But let's write some benchmarks. So I guess we'll take a few different ranges here. So we'll do v4, v6, v6 with zone. So the IP is going to be a IP type. And the mask we're going to apply, or bits, is a uint8. So for v4... Oh, did I merge? I didn't think I did. I gave looks good to me, though. I only do optimization when there's a benchmark to check. Yeah, same. It's not worth it otherwise. I can go ahead and squash and merge this, though. This seems fine. All right, doing it. I know we're trying not to create merge commits in here. Oh, did both of us just merge that at the same time? I wonder which one took effect. Anyway, it doesn't really matter. I'll rebase. Or I guess pull. Oh, okay, excellent. I won. Nice. Cool. Good work. That's a lot better for sure. Excuse me. Okay. So for these tests, I feel like we want to which What kind of like mask do we want to use on these? Do we want to use like a /32 and then like a /128? Do we want to, in theory, have the loop proceed as far as possible? I feel like that is like the edge case, right? I guess let's take another quick look at the code. Prefix. Yeah, I think we probably want to do /128 and /32 because that way we execute the loop the maximum number of times. Is there any way to get TCP stream info and Go? Like if you wanted to track TCP retrains or window updates, maybe through one of the xsys APIs. We can take a look really quick. One sec. So Golang xsys Unix. By the way, I'm ashamed that I just said Golang out loud. I try not to, but for the website, you know, it makes sense. Anyway, TCP, let's see here, TCP info. Ah, here you go. Check this out. So get sockouts TCP info. So it looks like you would pass this a file descriptor, a level, and an opt. So these are probably some constants. You'd probably have to look like a man page, but this gives you this structured information. So I'm pretty sure this would do exactly what you want. But of course, this is Linux specific, so you'd want to put this behind like a build tag. So yeah, give that a go. I imagine that would work just fine. Yeah, we're gonna do this with the maximum length, I think, because that seems like the edge case. Oh, is that holistic, or could you query that during a transfer? I think you query during a transfer, I'd imagine. I imagine that, you know, you just take the file descriptor of whichever socket you're working on, and it would give you the information in real time. But honestly, I'm not sure. I've never used it. Let's see here. So 2020. Anonymous Go routine for like every second or something. Gotta try that. Yeah, let me know how it goes. I'd be curious. Okay, so it's dumping the kernel struct associated with the connection, updates as the network stack does stuff. Nice, that's awesome. Hello? I think I might have borked VS Code. All right. Back at it. Why did you pop up over there? There we go. Okay. Anyway, subtests. Yes. So I think I'll probably do these for /32 and /128. So I think that's probably the most reasonable. Do we have a must IP, don't we? Yeah, we do. Okay, so 2001 DB8 : 1 bits 128. And then we'll do the v6 with zone as well. I don't actually remember the APIs for that. Is it? I think it's the same actually. Yeah, I would say that's pretty badass. Wrap some Prometheus metrics around it, maybe. Yeah, totally. That would be pretty useful, actually, if you could have a Prometheus collector that gives you TCP metrics for a given netcon. That would be pretty cool. I think that'd probably be worth making a package for. I feel like somebody's probably done a TCP collector of some sorts, but this is my new side project. Nice, yeah, do it. Please do. Black Box doesn't give you that kind of info. Yeah, I think Black Box is more like high-level stuff. I'm honestly not sure if it does like TCP introspection. I know it can do like TCP, UDP, ICMP, but not like introspection. Hello, what terminal do you use? The standard GNOME terminal. I am lazy. I actually did try Alacrity briefly, but there were lots of weird things with it with my setup for some reason, and I haven't looked too much far into it. But yeah, I use the standard GNOME terminal. I have kind of gotten to the point with Linux where I will like to use lots of defaults for things because I just can't be arsed to configure every single little thing anymore, you know. But that's just me. Report Alex, probably be good. So each of these sub benchmarks, since memory is already allocated out here, we don't have to worry about like clearing the. We don't have to worry about like resetting the timer, do we? I don't think so. Okay. That's why you jam config and Nix. Yes, I need to do that for sure. Oh, you suggest a benchmark iteration for a half plus 1 mask, so /17/65 for v4 and v6 respectively. That will exercise how the loop behaves when it goes through every possible case. Don't touch the byte, mask a partial byte, and mask a whole byte. Yeah, that's a great point. We should do that. IPv4 128. Might be able to dedupe these a little bit. So, my thumb was kind of sore for using the trackball, so I got out my old Logitech Performance MX, and I've been using both, and it's very strange switching, but switch back to the trackball. Actually, I'm going to hit the bathroom. 1 sec. Be right back. Ooh, excuse me. Ah, where's my mouse? Is this on? No, it's off, of course. BRB. All right, sorry about that. Yeah, let's get back to work. So let's add a couple of cases, as Dave mentioned, for /17 and /65. That'd be a good call. I guess we could potentially factor these out. I feel like it's probably okay just to duplicate these and not do more like looping in here for now. So I'll probably leave it as is, but, or I guess we could do so bits as an array or a slice. I don't know. It's probably okay as is. I'm going to leave it alone for now. We can always refactor it. /65. Oh, this is gonna... Actually, it's fine. It's totally fine. We're not actually looking at the output here. We're going to discard it. We are just going to do the masking operation. I don't write benchmarks very often. It's kind of strange, actually, because I haven't done any like protocol parsing libraries in a while, which is where it really matters. But in this particular case, it does matter, so we do want to bench it. So 65. Okay. We want to report the allocations. So is this going to be one of those weird situations where we need to, like the Dave Cheney thing, like write the output to an unexported to a variable in the package level? Do we need to do that? I guess I don't know. So that way the compiler can't optimize it away. Frankly, I'm not really sure. I guess if it reports like very few nanoseconds, we'll probably know it's doing that. So error : equals IP prefix bits equals nil t fatal f failed to produce / prefix tt bits error. It's actually b fatal f, not t. Cool. So also we are, this is probably like one of the worst possible cases for benchmarking right now. I am streaming. I have lots of windows open. So these are not going to be representative of the actual performance of this thing probably, but at least we can have benchmarks that work. So maybe I'll have Dave check these out. Let's see here. I guess we could have just run my benchmark too. We'll do that next time. Oh, 0.001 nanoseconds. Yeah, I think this is optimizing it away. That doesn't seem right. Let's see here. So, yeah, that got optimized out for sure. Yeah, unless I just wrote the fastest possible code, right? What is that? That's like less than like a picosecond. IP prefix masking, stupid compiler, right? Okay, something silly here. Let's close this. We don't need it anymore. This file is small. Var prefix sync equals a netaddr IP prefix used to consume the results of the below benchmark to avoid the compiler optimizing away the calls to IP prefix. And Alt-Q, love it. Oh, we're within the scope of the package, so we can do this. So prefix sync. So I guess we'd want to declare the error above as well. So var error. Okay. Prefix sync. And these are not run in parallel, so this shouldn't be like a data race or anything, I would think. I think this is roughly how you do this, right? It's been a long time since I've written like benchmarks, honestly. So, anyway. Hello? That doesn't seem right. For the benchmark, you might want to ignore the error, boo, I know, to eliminate the effect of the branch on the benchmark. Yeah, you might be right about that. This is strange. I think you're right. The tests elsewhere would fail, wouldn't they? So it's still optimizing it away. Unless I'm just doing something really silly. Am I forgetting to like... So this is a benchmark. It's listed with the right name and everything. Report the allocations. Are you winning? Not really at the moment, I would say. I think it should be... Oh, yeah, I think you're right. I think it does need to be exported, actually. Looks right. I think the compiler is just winning. But yes, I believe you're right about that. I think it does need to be exported because that way the compiler can tell. The compiler cannot tell that it's not used elsewhere. So, must be exported. Yep. What? Okay. This is weird. I'm very, very confused with what's going on right now. There's no way it's that fast. Wow. Oh, Dominic's right. I'm so dumb. Yep. B.N. Yep. Yeah. Wow. So as you can see, I don't really write benchmarks that often. Sorry. I would usually copy and paste them from elsewhere. I wonder if we still need the sync here. There we go. There we go. Femtoseconds per op, but yeah, Daves, this is interesting actually. So it looks like the ones that exercise all the different branches actually are a little slower. I mean, of course, this is running on my my machine that's like streaming and everything, but it's quite interesting. Do I still need this? Let's just out of curiosity. Makes sense. We're seeing the effect of the CPU branch predictor. Yeah, that's wild. We do not need the exported variable. So what are the cases where you actually need that? Like, I know that's like I think it's like an entire like Dave Cheney talk, right? Is where he talks about the exported variable to consume the result of a benchmark. Because we don't seem to need it here. I mean, we could leave it in, but I guess I'd rather not leave it in if it's not necessary. So I guess above we are not... See, my convention is to like do underscore underscore. I think the function should be inlined. To check, add a second prefix op in the loop, verify that the bench time doubles. Yeah, I'm sure it would. Let's see here. Looks like about double, assuming that's what you meant. To check that the benchmark is actually running, I have trust issues with looks good to me. Yeah, this looks good. I think we're in good shape. I could potentially factor these out so that like these test cases are, well, I kind of want to do it, but it's also overkill. I guess it's fine. I'll leave it alone. Oh, Dave, your code wasn't formatted. I didn't even notice. Since you'll be reviewing this, I'll just go ahead and add it in. No big deal. You could check every mask if you want to. Yes, that is true. I think it would make it take a very long time, though. So, especially since V6 would be 128 different runs. With NixOS, I don't have Go format, and my default path in this project lacks a shell.nix. You could add one. So you're running NixOS in your desktop now, too? Nice. Add benchmarks for IP prefix. Asking Go format. Yes. Origin head. Why Nix? So a few of us, at least several of us in the Gopher Slack at least, have been really into Nix because it allows you to have like a fully declarative environment, which is very cool. So for example, I'm running NixOS on my router and my server now, and I can just go ahead and create declarative configurations for all of my things. It's great. Not convinced about NixOS on the desktop yet, so it's less effortless than Arch, to be honest. Yeah, true. I think Dominic and several others, possibly here, are running NixOS on the desktop. But I'm running on an infrastructure. This machine's Ubuntu 20.04 at the moment. Go ahead and request from Dave, and I guess I'll tag Crawshaw and Brad as well, just in case. I run Ubuntu on my desktop. Feels bad, man. Hey, me too. I don't run i3. I don't run anything fancy. Fixes number is, I think it's 39 actually, because I think 40 was a dupe. Your desktop is NixOS and your volume switch all systems. Yeah, one of us. It's great. So here is the pull request we're looking at, by the way, if anybody's interested. Yeah, seems fine. I started with servers. NixOS makes way more sense for servers. Yes, I would agree with that statement. I think it is awesome for servers, actually. So I think with that, I guess whenever that is merged, no rush, Dave. If you're taking off for something, it's not a big deal at all. But I guess with that, we can move back to what I was working on before, and I can explain why I went down this rabbit hole in the first place. Reviewing now. Cool. Okay. So we are done with netaddr for the moment. I cannot think of anything else I need immediately. Oops. Why did that come over there? There we go. Sometimes my it's kind of funny because like I kind of want like a tiling window manager just without the work of actually tiling. So I end up doing the keyboard shortcuts. Hello? Oh, right. There we go. Why does it keep popping up over there? That's so weird. Right, so the test case I was looking at that prompted me to go down this whole rabbit hole. I'll show you all. Where is it? It's in the config, I think. It's a config test, interface test, plugin test. I think it's test parse prefix. So test parse prefix. This one right here. So I made it so in CoreRAD, if you specify anything other than :/64, it is an error. So we copy the same magic syntax from RADVD, where if you do :/64, it will take any IP addresses with a /64 subnet mask on that interface and expose them as prefixes. And that seems to be like a pretty good behavior. But the thing is I cannot think of why any other value would be valid here, because why would you expose like a /56 or a /48 this way? Benchmarks look good. V6 plus zone is 2 times slower than plain V6. Is it really? I guess I wasn't paying attention. I suppose I could have checked in benchmarks, but they wouldn't have been very useful considering what I'm doing right now. Cool. Go ahead and merge that because we're going to use this code. Thank you, Dave, for the quick fix on the other issue. I don't know why. I don't know what was going through my head when I wrote that. Anyway, one of those goofy things. So if I go to internal config and we run this test, test-v -run. So check this out. Check this error out. Failed to parse prefix :/63. 000fe :/63 is not a CIDR prefix. I saw this and I was just like, what in the world is going on? Because the test is passing because I'm just checking that some error happens. I know this is the lazy way, but I saw this in the output and I just could not understand where that could possibly come from. But it turns out it was a bug in the netaddr package from the code that I wrote. So that's what we just fixed. Pull all the dependencies. Update everything. 1 sec, be right back. Sorry about that. I had the Nintendo Switch here docked at my work desk. I was playing Animal Crossing earlier today. You've always wondered, why isn't gomod tidy a default command after every go get? Frankly, I'm not sure. If Dominic is still around, Dominic probably knows more about this than me. I have no idea. I just gomod tidy by default now, because it cleans up the GoSom file. So now that we've pulled that change, we should see a new failure message. Koros, thank you so much for the follow. I appreciate it. We should see a new failure message, which is only /64 is permitted for inferring prefixes from interface addresses. So this fixes exactly the problem I was having. Beautiful. I can only guess, but go get something about to use followed by an automatic gomod tidy would be annoying. How so? Maybe because it would affect unrelated things. I guess, I don't know. I just do it by default. I just always tidy everything. Go.mod, bump, inet, netaddr to fix prefix masking bug. Oh, because it had removed the unused dependency that we just added. Right, right. Yeah, you're right about that. You would go get thing I will use in a moment, and Tidy would go, ooh, unused def. That's very true. Maybe I should make these tests smarter so they actually just, I don't know, like inspect the substring or something. But I don't know. Because we just expect some error to occur. I don't know. The thing is if you start testing like for individual like error strings, things can get messy in a hurry. So if I look at, go away, that. If I look at these, like I would have to factor out all of these things into variables or errors, and then possibly either do that or check for substrings. So I think in this particular case, it's probably fine. But now this case is covered, so we're good. Can anybody think of a reason why it would make sense to allow anything other than /64? Because for stateless address auto configuration, you need 64s or bigger. I'm pretty sure you could do Slack with like a /56. It'd be really weird, but I'm just trying to think of cases where it might make sense. I guess, for example, if you had like a 96 assigned to an interface and you wanted to like advertise that a 96 was on link or something, you could. I have no idea. I run /64s because I am not insane. So... Oh, what else did I want to fix today? So we fixed the bit twiddling portion. Upstream monitoring, right? Yeah. So I've been working on an upstream monitoring module. I can show you all where we're at now. I actually factored out a few things the other day and made it a lot tidier. So if we go to the monitor code. So what I ended up doing is I factored out a listener type here. When in doubt, wait for someone to complain and describe their use cases, otherwise stick to simple constraints. Yeah, I think I would agree with that. So what we had before in this code is we actually had to duplicate a receive loop with the advertiser. So CoreRAD has two possible network listeners. So we have the advertiser, which is right here, and we have the monitor. So the advertiser's job is to receive router solicitations and respond to router advertisements. And the monitor's job is to listen for any kind of NDP traffic that it can get and just go ahead and report on that with metrics. So the idea is that you send advertisements downstream, so you run advertisers for every downstream interface, and you run a monitor for the upstream interfaces, because, for example, I want to know if my default route is going to fall off, or if my ISP's router is no longer considered default. I can do all those different things. DL would be so much cooler if they didn't charge you for compute when it's powered off. I mean, I guess I get that, though, right? Like, you're still reserving, like, you know, you're still allocating disk space and possibly memory space, like, you know, reserved in the system. Are there places that don't charge you for when compute's powered off? I guess I don't know. I worked for DigitalOcean for a while, but I have no idea. AWS, interesting, okay. Do they charge for disk images? Probably. Oh, GCP, AWS, etc. don't charge when powered off. Interesting. So I know with DigitalOcean, one option is you could take a snapshot of your VM when it's powered off and just go ahead and destroy the VM. But then they charge you for the snapshot storage as well. I think it's just a lower rate. Linode is similar to DO. Okay. So GCP and AWS will still charge you for data used. Gotcha. But they can do that because they don't guarantee that your VM can start back up. You might hit start and be told, sorry, no capacity to schedule your VM. Interesting. Interesting. So I guess back to what I was discussing. All kinds of random stuff going on in Twitch chat. I factored out this listener type because I wanted to handle a lot of the common functionality between these two things. And before, there were a couple of loops here that were very similar. So the listener, what it does is it handles things like context cancellation. So for example, when the context we pass in is canceled, we will set a read deadline of some time in the past. In this case, I think I have Unix time 10. So if you set a deadline of a time in the past, it will immediately cancel any reads. So this read loop begins, and we'll start reading messages. And whenever a message is received, we will pass it to the caller through this synchronous callback. We had a discussion in the Go for Slack performance channel the other day about synchronous versus asynchronous callbacks, and this actually makes sense in this case. I'll try and spin up a VM with Prometheus Sandbox. Gotcha. Yeah, Prometheus is sweet. You should run it at home. That's what I do. I will actually show you what I did with Prometheus recently. It's pretty cool. So within this function, we have this receive retry loop. So we do retry logic as far as like reading from the connection. If we fail, we will continue to back off for a little bit before we accept an error as permanent and then return it. We also want to filter out things like an invalid hop limit. So any valid neighbor discovery traffic must always have a hop limit of 255 because that means it cannot possibly be forwarded by a router. So if you had a really bad misbehaving router, it would decrement the hop limit and forward it anyway. So you don't want that. So I factored out all this code, and as a result now, the monitor and advertiser listening loops are much simpler. So the monitor just calls mhandle and then calls a callback. The listener calls this handle function that does a lot more things. So what I want to do is demonstrate kind of where we're at this point, and then we can describe, I guess, what's next. So I need to pop open my terminal? No. Well, I guess first of all, I can show you all Grafana. So what I'm working on with my Grafana stuff. So I guess, let me pull up LastPass. Grafana. Good luck guessing my 20-character random password. I'm not sure how it's going to display, actually. So I have a dashboard now. Very nice. Might not display as nice if I zoom in, unfortunately. It's probably fine. So this is the production instance. So I actually set up a separate Prometheus job for the production versus the lab. And I finally have a separate lab job for this because I kept breaking things on my production LAN, which is bad. So in prod right now, I'm running 025. It was built on May 22nd. We are advertising prefixes to several different interfaces. There is no monitoring functionality. Excuse me. We are sending router advertisements, sometimes listening to router solicitations. We are mostly doing unsolicited multicast router advertisements. But if I flip over to the lab instance, I'm actually doing a build here locally where I have this version without CGO because NixOS requires you to not use CGO. So this is all statically linked. And now on the lab VLAN, we actually have a separate instance running, which is doing things like the upstream monitoring. So for example, checking the amount of time left on my default route, because if this goes down, I want to get alerted by that. And also the number of router advertisements I'm receiving from my ISP, because my ISP is really silly, and for some reason they send like three router advertisements like every 3 seconds. It's very strange. But yeah, so this is kind of where we're trying to get to. And we can also verify things here like the inconsistent information. So if I can spin up a VM and actually verify that we fire alerts when we get inconsistent information from other machines in the network, which is pretty cool. So the goal is going to be to promote roughly this build to the new version, but I'm trying to see if there's anything else we want to do first. And so the way I did this is through Prometheus. So get the creds for that. Wrong one. So if I go to my Prometheus targets, we are exporting metrics from lots of things. So first we have CoreRAD 9430, and we also have lab CoreRAD. So I actually created an explicit lab job because this way I can fire alerts for just the production instance and not the lab instance. So if I go to my Prometheus alerts now, we have lots of alerts set for things that are possible bad conditions in the network. So for example, if an interface is not advertising two prefixes, which have the prefix of my /56 from Charter, as well as my /48 ULA, I want an alert because that verifies that a prefix has fallen off an interface, which for some reason keeps happening to me. So DHCP CD will drop a... For some reason, it will drop a prefix delegation to an interface, and I have no idea why. And if I restart it, it'll come right back. So I want to swap that out for network D, I think, but I just haven't done that yet. So when this happens, though, I get an alert, which is pretty cool. If an interface is not sending multicast router advertisements for a long period of time, we want to know about that. If any of the interfaces are not configured for Slack, because every VLAN in my house uses Slack, I don't want to use DHCP v6 in a stateful way. We want an alert for that. Let's see here. So we got a few different things like that. And then as far as the upstream stuff, these are what I'm working on right now. So I want to know if in 2 hours my default route will expire, because that's bad. That means that none of my v6 will work anymore. So for example, I set up a firewall rule the other day to drop my ISP's incoming router advertisements. And as a result, the default route was going to fall off in less than 2 hours, so I got an alert. Pretty cool, huh? And the other one is if we've seen no upstream router advertisements for more than like 5 minutes, because in my case, the ISP is sending them every 3 seconds, so I should expect to see them for 5 minutes. We'll also fire an alert. So this is why I think this is valuable. This is pretty new functionality kind of created because I was having trouble with Charter like randomly dropping my advertisements and such. So now we have this in this nice dashboards. I need to publish my alerts somewhere. I have not done that yet. But what else can we add to this? So like what exactly is useful in a network that you'd want to know about as far as like v6 functionality goes? I have one of those days where it feels like your throat's like kind of like phlegmy. It's just gross. Sorry, I got a message I gotta check. One sec. Yeah, yum is right. Super annoying. Right, so we can actually hop on my router really quick and we can see what they're sending us and see if there's anything else worth alerting on, but I'm not sure that's actually the case. I guess I could where's my... Oh, it's up here. I guess I could potentially monitor for incoming like neighbor solicitations, but I feel like at that point you're getting into like weird territory. As long as we're seeing router advertisements, we should still be fine. We should count on the underlying neighbor discovery algorithms to do their job. So, no, I want the router. Yes. NDP listen -I enp1so. Oops. What do you mean no such file? It's not executable? What about MAC spoofing? Same MAC on different interfaces. I guess I'm not sure what you mean. That's really weird. Why can't I... I guess I could just compile this on NixOS. It's probably the same way to do this, right? Let's see here. So source NDP. Oh, great. It can't find the loader. Oh yeah, so I think I SCP'd the binary. So we can just go ahead and do this. And this will work. I should probably just get this tool packaged, like my little NDP tool I wrote. You can't do that next West. Yeah, I think I've done it with CGO disabled a few times, but anyway, so now I want to set cap. Yeah. We just need capnet raw because we want to open ICMP-v6 sockets. So, NDP. Do the whole password thing. Fun. Right. So, pretty soon here we should start seeing some router advertisements coming in. There we go. So I find it very strange because I'm getting like 3 arrays from the same MAC, and one of them has prefix information, the other 2 do not. But I don't feel like the prefix really tells me anything that useful. Like, it mentions the prefix that my WAN interface is on. It mentions that prefix, but there's no flags in it. So like I can't use it for stateless address auto configuration, anything like that. The router lifetime here is the default route. I don't know if there's anything really useful to monitor here otherwise. So I guess we could... There was something I was just thinking about that I wanted to add, but I can't remember what it is. Something related to the monitor code. Are there any more Prometheus metrics we can expose from this that'd be useful? Oh yeah, this was funny. I was briefly considering... part of me wondered for a sec if it made sense to integrate a DHCP v6 client for the purposes of prefix delegation, but then I realized that would be totally insane. Like, that's definitely overstepping my boundaries a little bit. Plus, since systemd networkd can do that now, I feel like there's really no point. I'm still running DHCP CD, but I would kind of like to get rid of it. CPC. Yeah. Anyway, what else what was I going to look at? There was something I wanted to fix. I'm all over the place today. We've got a lot of tests now for things like the retrial logic and everything, which is good. I'm pretty happy about that. I feel like there was like one more metric I wanted to export, and I just cannot for the life of me remember what it is. We do have much nicer metrics now for the array verification. We actually expose like a details field and everything, so you can verify which field exactly was wrong, and in particular, like if the prefix was wrong, you can check that as well. So actually, check this out. I can pull up another window here, and we can show you that. I'm going to need to SSH into a VM in my lab, I think. Ran out of water. I'll be back in a sec. Okay, we're back. So I'm going to show you all, I think, something I've shown on stream before, but this is actually pretty cool. So if we, let's see here. So I'm going to boot up a virtual machine in my lab, I think running FreeBSD, and we can actually run CoreRAD on FreeBSD too, which is pretty cool. As far as I can tell, most things work fine. We do need to integrate support for fetching the system forwarding state and such. Maybe we could do that. Maybe that could be fun for today. I don't know. We can at least like investigate it, but I need to spin up a VM. So virt manager. It's already running. Cool. What's the address on this? I think it's probably the same. So let's SSH into that thing. Isn't it lab FreeBSD? Yeah, I think so. There we go. So this is a FreeBSD VM running on my lab VLAN. So, oh yeah, IP doesn't work. If config, great. So this is running. You can see here, so we have my /48 and then the 2. I use this as my VLAN ID. So this is running in my lab VLAN, which is VLAN 2. We actually have a small config file on here. Where is it? I thought I had it. Oh, it's here. Oh. Feeling inspired, just spun up an EC2 instance and start developing that Prometheus exporter. Nice, awesome. So you can actually, the config file is exactly the same. So in this case, I'm going to advertise on VTnet0, which is my virtual network interface. We're going to do ::/64, but we're sending back a preferred lifetime of 10 minutes, which is much less than my router. So if other machines in the lab saw this, they would get confused, which is good. So we can actually alert on this. So I need to create another terminal. With the presentation profile. Where is this? The router? Yeah. So I'm running my lab instance of this in screen, or tmux. I'm lazy. So this is the lab instance. You'll see it's noting here the router advertisements for my ISP. I feel like this is not really useful. Like, do I want these in the logs? I think I might need to add a verbose mode, honestly. But what's cool here is if I run CoreRAD over here, this will actually send out an inconsistent advertisement with the one running the lab. So... // hello? Command, there we go. Hey, check it out. Actually, I should pull the latest. We changed a lot. So you'll actually notice here, we can tell that, for example, it noticed some inconsistencies. So other configuration, we want true because that's what we're specifying, but this router is specifying false. This prefix, we are advertising a preferred lifetime of 4 hours. It's advertising 10 minutes. So we make all these changes here, and we can actually check this now. So if we do, oh gosh, the key bindings. Localhost 9431 is the lab instance. Grep inconsistencies. can actually see we are exposing Prometheus metrics, which tell you the field where things went wrong and the number of advertisements we received with an inconsistent configuration. So you can actually alert on this, which is very cool. So RADVD, I believe, will log this, but because we have Prometheus support, we can do a lot more cool things. So these are the kind of features I really want to add at this point, like quality of life things, you know, like what could go wrong in a network and what could we do to alert on that. Yeah, we should rebuild this on the BSD system anyway. So I think we're done with this for now. Close this out for the time being. So on my FreeBSD VM over here, let's see. So make. Pull the dependencies. Oh, right, I need to run gmake. Because I have a, let's see here, make file. So I've got a make file here that just does a couple of quick little things. It will actually... Oh, you haven't done Go in a while. Is GoPath still a required thing or not? Just skip it. I would do modules for sure. Modules make your life a lot easier, honestly. So we've got a script here that will actually give you information about the build of CoreRAD. So in this case, it will tell you if you're running off of a tag, if you're running off of a certain commit, when the version was built. So we can actually build it with no cgo as well. So in this case, since we're on FreeBSD, if I just run gmake, because we want the GNU make, this will produce a new build. Command. So you'll see now we are running 02526, so I think 26 commits after. And then GAA, this is probably the latest git tag, right? So git log -1. Yeah, git AA41B83. Yep, perfect. So you can actually tell which commit you're running to, which is pretty cool, and when it was built. So this works, but I think this is the problem here. This is kind of what I was thinking about looking at. So on FreeBSD, we can't look at network state changes because I don't have a file system or a watcher implemented for that. So I wonder if we can implement this kind of functionality for BSD. That could be kind of fun, right? Excuse me. But also the Linux stuff needs a bit of a rework too. Maybe we should start there. So I created this package I call netstate, and the basic idea is that it pulls out all of the state for, let's see here, where does it live? Server, I believe. So I created a package I call netstate, and I initialize it up here. Yeah, netstate new watcher. So this is an OS specific like file system or network state watching package. You tell it which kind of changes you're interested in, such as network links up and down, etc. And it will actually listen for the OS-specific mechanisms, things like netlink, for example. But the problem with this is that I'm pretty sure we can't abstract these in a clean way, or at least I don't know how yet. So I think this is probably a premature abstraction, and I kind of want to pull this code back into the repo and keep working on it. Because, for example, if I look at the code for Linux that checks the changes, where is it? Notify, watch, this one. Oh, OS watch is what I want, right? So on Linux, we are dialing out to route netlink. We are looking for RTM group link, so link state changes. We're also going to want to watch for IP changes. I think that'd be useful too. We're receiving netlink messages, and then we're kind of merging them all into these one operations, but I feel like this is not really what we want. So I think we want to pull this back into the repo and give this another look. So the BSD thing is worthwhile, but I think I should probably figure out what I want to do next and write some issues so I can actually keep track of this in my head. So let's see here, MD layer, CoreRAD. A couple other things here too. Config reloading, we could do that. I don't know, what do you all want to see? I've got a couple of ideas for things we could work on today. Config reloading could be kind of useful too, because that way you don't have to drop the default route for every client when you reload it, which is annoying. Let's see here, internal netstate. Move back in from external repo and rework. Factored out of this package a bit prematurely and could probably use more work. We should pull it back in and re-evaluate the situation on Linux and start BSD. Okay. So we got that. The config file thing could happen, and yeah, we need the BSD like auto-conf forwarding configuration. So I guess here's a question: is there anybody here who'd want to run this on BSD? Because if there is, that would motivate me to work on that. But if not, then I probably won't worry about it for now. It is cool that it mostly works on BSD, though. What is going on? So I guess if not, we could work on the network state thing. That'd probably be useful to at least start examining it. Because config file reloading is also a thing I want to do. That would involve like canceling the entire, well, we'd either have to like cancel everything or possibly like take a mutex and swap out the configs in place. I'm curious which one of those would be easier. Right over here. Right, okay. So let's leave the BSD VM alone for now. We can pull this back in. It's probably not a bad idea. So net state into internal. So now we have this net state package back internal again. We're going to remove all of the unrelated files. So remove. Does not need its own Go mod anymore. Does not need its own license or README. I could actually probably do this a lot faster in here, couldn't I? Net state. Move the test file, remove the README. I think the rest of this is probably all valid. But we would need to change the import paths as well. Let's see here. So CoreRAD internal net state. Yeah, it's kind of a... I have a tendency to like factor out like helper packages perhaps a little too prematurely sometimes. So I think this is one of those cases. I think we can do better if we think on this a bit more. Does this work? Okay, seems to. Okay, so we've got this back in the repo. Let's switch back over to this version. So netlink v11. Yeah, I guess that would be the case now. We'd be pulling this in because we're actually using my netlink package directly instead of through netstate. So let's change the import path here. So CoreRAD internal netstate. Yep. And now we're probably gonna have a bunch of compilation errors because the types are not equal. So I wouldn't have expected that to work. Let's see here. I spelled it wrong, didn't I? Yep, lots of things broken. Okay. Probably could have done a mass search and replace, would have been easier, huh? What are you gonna do? Internal, and what's broken? Advertise, monitor, server. Right. So, swap this, and then the monitor as well. And then I think we're gonna start looking into that again. Advertise Linux test. Okay. One more time. Awesome. Test pass. What's cool now is I got the test loop down to like half a second without the integration tests, or without the test to spin up a Vth pair. It's a little slower with that, but the actual normal tests take not very long, which is nice. So if I do cover, what's our coverage? 83.4 without the integration test. That's awesome. Pretty happy about that one. So, I think it's time to start looking at netstate again. Once we can get this to build. Does everything build now? And does a test. And I should probably run static check because I always forget. Ah, test failed. Internal system. This is something I factored out yesterday too. The internal system stuff is still failing. Weird. Okay, maybe I accidentally broke something. I could have sworn it was passing the other day, but let's fix this really quick. Let's take a look. So, so we removed netstate from the Go mod, right? So tidy. Okay. So, internal nets. So internal, we make changes to all of these. Oh, we've got a submodule, don't we? Oh no, no submodules, no way. Maybe a netstate already has enough useful data. You mean as far as like the TCP info? I mean, it might, but I think it'd still be pretty useful to have the information on individual connections. You know, internal. Oh, new file. Was that the submodule thing? I think it was. Git restore stage netstate. Netstate. There we go. Okay. And clear. Internal netstate. Pull back in from github.com mdlayer netstate. Perfect. And go dot star. Remove github.com mdlayer netstate. Okay, so let's figure out why these system tests are failing, I guess, before we dive in any further. You're thinking more about tracking connections intra-cluster or between DCs, even to try to notice traffic patterns only in certain hotspots when they come up. Gotcha. Yeah, I think I'm pretty sure the Prometheus node exporter exports a lot of that via metrics anyway, so you can take a look at that and possibly see what it exposes instead of like scraping netstat. Also, don't use netstat, use SS. Netlink for the win. Internal net system, right. I think I subtly broke this test. I'm not sure how. Let's find out. So these are tests I wrote yesterday. I wanted to factor out some of the retry logic and actually do tests for it without having to set up like everything else in the system. So dialer test. So the unprivileged dialer test is failing. Okay. Expected permission denied, but got Uh-oh. My, it just says my static analysis failed. What did I do now? Forgot to run static check, didn't I? That? Okay, let's check, guess let's check GitHub Actions. See what's going on. Ah. Need to silence the phone. Process completed with exit code 1. Oh, file missing license. Oops, that's silly. Okay, we can fix that really quick. How silly of me. Forgot to add license headers. The usual. I really should run a lot of my stuff locally before I forget to, you know. Probably an easier way to do this, but we're doing it this way. It's fine. License headers, yeah, totally. I mean, with Apache, it's the best practice, right? So I've just been trying to follow whatever people deem as the best practice for that sort of thing. Scripts CI build. File is not Go formatted. What do you mean? It's looking like Go please is a little borked at the moment, so let's go ahead and restart that. Oops, why does it keep popping up over there? Let's not go for a minute about this. RT.link added to user dictionary. Yes, good. Is it this? Is it the link message? No. Oh, it's these. Okay. You don't need to specify the type of the within a map, right? Yeah, I can remove the type here, so that's why it's failing. Okay. Simplification. That's fine. Internal net state. Yes, I do check for gofunct-s. Yeah. nice to tidy things up, you know. By license headers go fumps-s. Yeah, I don't know why that's not the default, to be honest, but who knows? Yeah, I agree. It is a little bit sad they made -s a flag instead of the default. Yes, I totally agree with that. I'm not sure why they would do it that way, to be honest with you. I find that quite frustrating as well. So, system contest. No. Yay, networking. Yeah, I should add more stuff to that list too, but I think that's probably a pretty good start. So what is going on with these tests? Why are they failing now? It's just the unprivileged test, isn't it? Yeah. I think I probably broke this. I think the privileged ones probably work fine. So if I run... So if we do this, we needed to... These also fail? They also fail. Huh. So I've got something subtly broken. That's really weird. I thought it was passing upstream, though. Or in the GitHub Actions stuff. It does. That makes no sense, right? I mean... Run package system integration test. Yeah, it's running... What in the world is going on? I'm going to shrink this font size really quick. I know what's going on. It is actually pulling from it's pulling an address or an interface from my actual system because we need to actually set up an NDP socket in some of these cases. And this EMP5SO is my 1 gigabit NIC, which I think is not configured right now with Network Manager. EMP5SO. Yep, that's why. How silly. Okay, let's make these tests a little smarter. That is why. The code's not broken, just my system is no longer in a state that it expects, and my test is silly. So, dialer test. So we need an interface that has a MAC address, so like not a WireGuard interface, and also should have a link local IPv6 address. So let's look for both of those things. So let's have a MAC address, i.e. not WireGuard or similar, and an IPv6 link local address. Yep, so we need to check the addresses of the interface as well. So adders error. The addresses failed to fetch addresses. So what we want now is we want to detect the first. We want to detect a link local IPv6 address, which should be pretty easy actually. So. That's all a bool. So we need to do type assertions here. So IP, these are all IP nets, right? Aren't they? So IP net, okay. Net, IP net. If not okay, continue. So if not okay, actually we can just do this. So if okay and IPN.IP is link local unicast. Oh gosh, I need to check for v6ness. Okay, we're pulling in netaddr. I'm not dealing with this. Actually, I think I have code that does exactly this, like somewhere else in the code base. But where? Let's grep for it really quick. Just link local unicast. Plugin. Yes, I think the plugin code does exactly this actually. So we can steal some code we've already written. So that's good. Whole thing is kind of silly, but we are working on the netaddr package because some of us are unsatisfied with the current state of the APIs. Oh, just grep for, yeah, that's, yeah, exactly. Thanks for the tip. So it's funny here because I mentioned earlier I don't like else, and I have this big block here and then this else. So I kind of want to fix this too. Do we not check for v6 on here? We don't check for v6. I'll be darned. I think I just found another bug. Wow, what is going on today? All right, let's get back to that in a sec. So, yeah, we can panic F. That's fine. System. So it has to be a link local address and it has to be v6. So if is link local unicast and is 6, then we found one. And we break the loop. So if our address is not nil and we found a link local address on the interface. Actually, I guess we could check this first, right? We could check this property first. So if it equals nil, we continue. And if we have this, we break out of the loop. Because we just need a link local IPv6 address. We don't actually care which one. So now I imagine these tests will pass. Excellent. Which test or which interface to run on? Oh, yeah, this is all the simulated stuff. So let's do the privilege test. Okay. System test. Netlink was created by Alexei Kuznetsov, and I did work with a guy named as such, but it seems that this name is very common in Russia, and there are hundreds. So I'm unable to figure out the same guy. Yeah, that's... I wonder. I don't know. 7 Deuce GL, thank you so much for the follow. So we have the privilege test now, and they appear to be running just fine as well. So, yep, ENP4S0. Perfect. That's exactly the interface I have configured. This works just fine. What a silly thing. So what I want to do probably is reconfigure both the interfaces of my system, but this is fine. Excuse me. So this will handle multi-home systems better. Must have a MAC address and an IPv6 local address. Yes. To open NDP con. NDP con. Yep. Kind of funny how you have to do like all this verbose logic to like look at the properties of an IP address, but such is life, you know. Star internal system. Handle systems with verify interfaces. Verify integration interfaces have IPv6 LLA. We contributed to the same UPnP project a decade ago, I guess, and he used to work with lots of networking stuff, so I bet this guy. Oh, that's pretty cool. Nice. I got a ping on Gopher's Slack a while ago. Weird. Yeah, apparently some of our stuff, the what do you call it? Benchmarks we wrote earlier are a lot slower with the zone. I wonder why. Have to look into it. So that fixes the immediate issue, and now we have the other problem. So again, more rabbit holes. So this doesn't actually verify this is a v6 address. So if I put a v4 link local address on here, this will not work. So that's bad. We want to fix that. So, because v4 has link local, they're just not used as often. I think it's the 169.254/16, I want to say. Link local IPv4. Yeah, 169.254.00/16. Perfect. Okay, steal that. Let's write a test. We can make the font bigger. My apologies, I forgot. There we go. Back at it, back at it. Okay. Standard from IPnet, scene prefixes. I guess while we're at it, we could try and fix this code a little bit, make it cleaner. So let's go full screen for a little bit. So we want something that turns netaddr IPs into RA options, I think. Or modifies a router advertisement, like an input RA. Yeah, let's factor this out. I mean, I guess it's not that bad to have this big if-else, but it's kind of bothering me, so I think I'm going to factor it out. This will go at the end of this loop now, I think. So func p prefix apply prefixes. So the input prefixes are netaddr IPs. Are they IPs or are they IP nets? I think they're IPs. What else do we have here? And we apply them to a router advertisement and return a router advertisement as well. NDP router advertisement. And I guess in this case, we're going to be manipulating it directly, so we don't really need to return it. Because we can manipulate it through the pointer instead. So P apply prefixes, prefixes array. So now we can go ahead and refactor this a bit. So we'll pull all of this out. And then for the opposite case, so if it is not unspecified, so that means you specified a concrete prefix, you want that exact prefix applied. Oops. Do you pre-allocate options? I think in this particular case, I do not, because I don't necessarily know how many will be applied, but I guess I would, wouldn't I? Because in this case, we could allocate the number of prefixes as the input. So yeah, we could do that. That's a good idea, probably. Excuse me. I don't think it... Ugh. Gross. I don't think it really matters that much, but the thing is that this code is only run basically on startup or when you reconfigure an interface, so it's probably not that big of a deal. But I like to go by the philosophy of if you know how many elements are in a slice, you might as well do it. So gross. High tier streamer. Yeah, I'm a god tier streamer, right? Not even close. I'm having a good time doing this. I hope you all are enjoying it too, you know. We take the IP directly and apply it. Yes. Komodo hype. What is that emote? Oh, apparently I have that too. By the way, so for the folks who are subscribers, we do have more emotes now. We have 3 tier 1 emotes available. Enjoy. You know you want to subscribe. I'm kidding, you don't have to. But if you have a Twitch Prime subscription, you can subscribe for free and get emotes. So definitely do that. User specified an exact prefix. So apply it directly. Love it. Well, let's see if we can hit somebody with a raid later. But I guess it's more likely. I guess I'm not sure how long Stoppelberg is going today, but maybe he'll hit us with a raid. We'll have to counter raid with our own emotes. Yeah, today was a weird day. I probably won't stream tomorrow. I think I should probably take a day off. But we'll see. I might actually stream on Friday. I have a day off work. So we'll see about that as well. Oh, that's weird. Long time you don't do network programming on Linux. Do you know if Bpf filters are currently supported? Yes, they are. I would think so, but not sure. Yes, Bpf filters are supported. You can actually apply them to, in Go, I assume you mean. You can actually apply them using xnet Bpf, which I have contributed to. So Golang xnet Bpf. This is a Go package. One sec. This is a Go package for building Bpf filters, and I've actually used this several times. And I actually contributed a virtual machine to this, so you can provide your instructions to this virtual machine and actually run tests on your instructions. So like you can simulate like Ethernet frames and it will actually run your program. So yeah, I think it's pretty cool. So yeah, check out xnet Bpf. I have used this to great success. You probably will need to use the, congrats, nice, yeah. You probably need to use the, what do you call it? The xnet IPv4 or IPv6 packages to get access to the set Bpf methods. It's not built into the standard library stuff, but it is in the subrepos. So if you open up xnet v4, v6, depending on your socket, you can apply Bpf filters and etc. And have a lot of fun. So yeah, enjoy. Bpf filters are super cool. I actually was considering doing them for my NDP project as well, but there is an ICMP filter type built in, which is very easy and makes things easy for me. So no need. Where were we? Right, fixing this. So in this particular case, we don't pre-allocate here because it's possible for a v6 serving interface to have lots of addresses in the same subnet. So for example, oops, wrong machine. Let's see. Yeah, so right now, my desktop, for example, has 2 addresses in the private, in my link unique local subnet, as well as my global subnet. I think my server has like a dozen in each. It's ridiculous. Yes, if you're writing eBPF in pure Go, take a look at the Cilium package. It's very cool for sure. All right, one more refill, sorry. It's kind of warm in here. I keep like drinking water to like cool myself down, like that OBS oven thing is real. So I'll be back in just a sec, sorry. All right, we're back. Yeah, definitely check out the eBPF package by Cilium. I bet that'd be super cool. Is there any tricky way to determine path of TCP session once established? DF bit on header maybe, then send file? Frankly, I don't know. I actually haven't done very much with TCP like internals. Yeah, it's just one of those. It's like the one protocol like at the lower level I haven't really analyzed that much because a lot of the stuff I'm doing has been at like Ethernet or IP level instead. And UDP, of course, but UDP is easy. So, if not asking too much, do you know the underlying C headers that declare these opcodes? Opcodes for what exactly? Like BPF? Or did not find them when I looked for, not even kernel headers, but someone suggesting copying them from the Ubuntu tree. Ugly. Yes, for sure. So actually, a lot of the constants and stuff should actually already be present. BPF, yeah. Well, you can use the xnet BPF package and these high-level types. It will actually assemble them into these raw instructions that are the opcodes. So you would actually write like high-level Go syntax and then use the assemble function here, which produces these raw instructions, which are then compatible with setting into BPF filters. So this should work, I guess, if I understand your question. But if you need like a list of like constants, then you can look at xsys Unix, because xsys has lots of like hundreds and hundreds of Linux constants in it. Let's see here. So like if you ever need like a syscall constant, like there are a lot of them here, and it's really easy to add more too. But otherwise, yeah, I would think that. Oh, you have C software that needs them, just didn't figure it out yet. Yeah, I would think that you could. I would think that you could write them in Go and then use this raw instruction thing, and then like write these in like out in binary or something. Oh, no worries. Yeah, the thing is like I've never done BPF filters in C. I've only done them in Go. Although the thing is the Go interface is very similar to the C interface, just it's more high level. Yeah, I mean, the thing is like, I don't mind, oops. Oh, goodness. I don't actually mind, what do you call it? Like, off-topic questions or anything at all. You know, like, I'm happy to talk about whatever. The thing is with the stream is that, like, it can be very fluid, you know? What were we... Apply prefixes, right? Yeah, that's right. The BPF package I showed is only the old-style BPF, like, just the classic filters on sockets. eBPF is a totally different thing. Apply prefixes, unpacks prefixes into RA, into NDP prefix information options within RA. Yep. So we need to extend RA by at least that much. So we can't just make it on the spot because we don't know what order the options are being applied in, but can we... How do you extend a slice and go? Would you do that by... That's really... Huh, wait a sec. I know there's like a slice tricks page. One sec. Delete, copy, append vector. I guess we could create a vector and then append it directly. Expand. Okay, here we go. Yeah. Extend. I think this is roughly what I want, yeah. So we append A with empty space and then append into it directly because we'll have the space allocated already. Check if cap is big enough in reslice, else allocate new slice and copy or use some append magic. Yeah, I think this is exactly what I want. I want to be able to extend it this way. So I just go ahead and append it with make space because make will allocate new room for it and then it'll all be written in place. So I think that's exactly what I want. So roughly RA options equals, it's weird. It's the kind of thing you don't do very often, so I didn't think about like how to do it, but options make array NDP option and prefixes. So this will extend the length of the slice. Oh, we want to extend the capacity. We don't want to extend the length, right? We want the cap to be the same. Oh, no, this will extend the capacity. Wait a sec. You know, I'm starting to think here, maybe I just want to be less tricky and just allocate a slice directly and then just append into it, right? So like if I do like opt NDP options, length prefixes, and then RA options equals append RA options with opts. That'll work, you know. Pre-allocate space for prefixes, as we know, since we know how many are needed. And I guess if I wanted to, I could add like a special case here. Zarkov, thank you so much for the follow. I guess if I wanted to here, I could add like a special case for one to just append directly, but I don't know, the whole thing's kind of silly. I'm sure this will be fine. So let's verify we didn't break anything first. We did break something. Nil nil. Oh, yeah, I think I did something silly here. So, this is why. 0. Yep. Yep, exactly. I had allocated with length 2, capacity 2 instead of length 0, capacity 2, which is what I wanted instead. So, yep, good call. Good call. I think we spotted that at like the exact same time, or, you know, the internet latency, you probably spotted it before I did. But anyway, it has passed. Perfect. So what we wanted to do in the first place is check for the v6-ness of the address. So we'll do that in a sec here. Plugin. Internal, plugin, refactor, prefix, apply, logic. Yep. And now we need to check the v6-ness of the address. So we want to write a test case with an address that is v4 and verify it gets kicked out of there. So we already have some. We have a v4 address, but we're looking for :/64. Yeah, okay. So what we want to do here is we want to make sure that, like, I mean, this makes no sense, right? This is gonna panic, I'm sure. One sec. It does, yeah. Yeah, let's test this. Let's test this in a different way. So we might need to write a special case function for this, actually. Or have this return errors. I don't think it does right now. None of these ops can error? Really? Oh, they can, but they just don't. Huh. I guess we can write another case here. Prefixes, we'll do a /8, and we'll just verify that a v4 or a v4 link local address or something does not get picked up. Actually, we could do 16 because that would fit in the range. Or we could do /32. Hi there, hello. Welcome. This is gonna be kind of silly, but so /32. Right, plugin. Prefix. And the addresses function should return a couple of addresses here that would not make any sense. So, like for example, 169.254, 169, or I guess 0.0.0.0.1, /32. So I guess what we want to verify here is that this just gets filtered out and we don't return anything, right? I mean, I think that would be reasonable. Like, or I guess we could add like one v6 address as well. I think we're at the point now where we can close that for a while. Write tests over here. So, what am I missing? Right. Okay. That goes within the plugin, doesn't it? Yeah, because we override the function. Okay. And then the output router advertisement, we would expect to have no options. Or actually just one option, just the one prefix of the 2001 DB8. So we'll copy that. Okay. This is going to be /32. Even though we don't permit this anywhere else in the daemon, I think it probably makes sense to validate this anyway. Import cycle. Do we not qualify plugins with name here? Oh, right. No, this is this package's concept. Okay, cool. And nil. How does this pass? I would expect this to fail because this is link local as well. I'm looking at the wrong package, aren't I? No, I'm not. Huh. Alright, let's run just this one test really quick. I guess we'll do the tmux split thing again, so that way I can get my webcam out of the way. Dash v dash run. What's this test called? Test build. JWL1, thank you so much for the follow. Automatic prefixes /32. What is going on here? I don't understand this. Doesn't really make sense. Okay. Print line. Some good old printf debugging, you know. Yep, so we get the v4 address, okay. Link local unicast. Is it not link local unicast? Thank you for the stream. Great content. Yeah, of course. I'm happy to stream. This has been kind of a weird day. I feel like I'm kind of off my game a little bit, but thank you all for bearing with me. So 169254. Why isn't this? What's going on here? I would have expected us to require a V6 check here, but we don't need one apparently. So what's going on? Hey, Stoffelberg, thank you so much for the raid. I appreciate it. Welcome, welcome. Fight back against the raiders. Yeah, thank you very much. I appreciate it. I hope your stream was good. I caught about I think hour and a half of it or so. Yeah, it was really interesting. I just I found a bug in one of my things and I kind of got an itch to get going, you know. So did that. So these are both /32. And the prefixes bits are also /32, right? I mean, P prefix bits. 169254. Yeah. IP0 is 169, IP1 is 254. What in the world? What am I missing here? This really makes no sense to me. IPP.IP. Wait a sec. Yeah, the IP address is still link local unicast because it's 169254 and it's v4. Is this one of those annoying v6 mapping things? No way. That is true. What in the world? I just don't understand why. I don't understand if it's link local unicast or... I think my Boolean logic is wrong here. Yeah, so I thought it was one of those v6 to v4 things too, but this is actually not because we're using the netaddr package, which makes that much more explicit. So... if it is link local unicast, oh god, oh, I'm so dumb. I see what's happening. So the problem is that I was reading my test totally wrong. So the problem is here is that we want to filter link local addresses because we can't advertise them on link. So what I want to do is I want to specify an IPv4 address that is not a link local address, and then it will get by. Wow. I should just read my docs. See here, only advertise non-link local prefixes that also have a matching mask. If I had just read that comment, like, I would have saved myself just the past 5 minutes of frustration, you know? 192.021. There we go. So now we have an NDP prefix information with a v4 address in it. So we found the bug. Ridiculous, right? So this includes the v4 maps v6, which we don't want. So if it's 4, we want to skip it. Wow. That was brutal. Specify an IPv4 address that could feasibly be matched, but must be skipped due to incorrect address family. Wow. How silly. Okay, we fixed a bug. A very subtle one that can't actually appear in the program because we, that was quick. Sometimes it takes days to figure out. Yeah, totally. I just had link local in my head so hard here, you know, but non-link local IPv6 prefixes. So elsewhere in the program, we verify that ::/64 is the only valid one of these things, so you can't actually match v4 addresses with that. However, this could have potentially bit me someday if I opened it up to like larger prefixes. So somebody ignored errors in prototype code. Yeah, I guess in that case, I would usually have like a snippet where I print out like the error message or something. Internal plugin. Skip IPv4 addresses in prefix apply. Yes. Error can't be non-nil if you don't look. I don't know about that. Wow, what a pain. That's so silly, you know. It's like one of those just like really silly little things you just don't notice. But anyway, what were we even working on? We were looking at the net state stuff, right? So I think probably what we want with this API is something more granular. So at the moment, you subscribe, you tell it what kind of changes you want, which is a bit mask. So you say, I want things such as link up, link down, link testing, etc. These different states. But what we actually want here, I think... Gianco, thank you so much for the follow. I appreciate that. I think what we probably want here instead is... instead of getting these changes back, you get messages related to that sort of thing. So we can actually get the raw route netlink messages, I think. And then we can inspect them for more information. I don't think we can abstract this away effectively per OS, at least not yet. So what I'm thinking here is we probably want to return a channel of like... maybe a channel of empty interface, and then a lot of type assertions to OS-specific types. It kind of sucks, but this is a pattern that... wrong tab. OS. Let's see here. This is a pattern that... what is it? OS file? Or OS stat? File info, right. So you'll notice here, this sys interface. So underlying data source can return nil. This is operating system specific, which will tell you basically like what is going on and like what metadata was returned with it. So I think probably what I want to do is return a structure with this sys thing and then allow the caller to type assert on it. It's kind of gross, but that way we can also inspect things like the route netlink messages and see what else we might possibly care about. So Maybe we just want to subscribe to all of the state changes on an interface and then like every state change and then require the calling code to filter on what exactly they want. I don't know for sure yet. So let's look at this. So what I've got right now, it will unpack route netlink messages into a set of changes, and it evaluates this operational state attribute and converts it into like one of our booleans here, or our booleans, our enums. So I guess my question is, like, do other operating systems like BSD have equivalents of like route netlink where you could subscribe to state changes for a given interface? Because realistically, we care about the interface's state going up and down. We care about... Do we care about addresses being added? I don't think so. We definitely care about addresses being removed because that would modify the prefixes we're advertising. So we'd probably want to produce an immediate router advertisement. Oh, you figured you'd try this out in some test file grab via HTTP, but getting at the FD and HTTP client isn't exactly easy. Yes, definitely not. You might want to try like Telnet or something instead. Or actually, you could do you could just open like a net. You could do like a net dial and do like a manual HTTP 1.1 like ASCII request. That'd work fine. You know. So I don't know for sure how I want this API to look, but I think I want to return these messages to the caller so the caller can figure out what they want to do with it. So. Oh, you might want the ability to do the same on a legit HTTPS endpoint too. Yeah, I think in that case you'd be getting down into the HTTP transport, possibly. I think would be the layer you want to look at. It's also worth keeping in mind that when a quick happens, you know, HTTP 3, your code will no longer be useful. So you're going to have to differentiate between H1, H2, and H3. So all kinds of fun, right? So maybe instead of having callers register interest in, didn't think of that. Yeah. Rough, huh? Renanulous. I thought at first that was like ridiculous, but is that maybe you're going for? I don't know. Thank you for the follow. So maybe we'll just, for now, we'll subscribe to changes in the interface. We can always change everything, and then we'll return a structure. We can return an event, which is going to be OS specific. So a channel of events, and events are going to be OS specific stuff. Struct. I guess it could potentially be useful to return the interface that it's on as well. So interface string and the sys. Net HTTP might not even export the struct stuff I need. It might be private. See, I'm pretty sure you can get at that layer though. I did an experiment with net HTTP where I was able to get VSOC working. So I was able to get VSOC working over HTTP instead of over TCP. So you can definitely make it work. Let's see here. Transport. Dial context. So if you do dial context, you'll get a netcon. So you would actually dial the connection here, and then within this, you can get the file descriptor of the connection. So this could work. I would look at something like that, I think. I think dial context is probably going to be your best bet. So we'll return a channel of events. We're gonna, all these docs are going to change and everything. We'll go back to it. Let's see here. So we no longer have the concept of changes you're interested in, and we have just interfaces. So a map string, which is interfaces, and then the listeners for it. So a channel that you can only send on. So channel of events. Yes. Channel of send only events. So within a given interface, so now I do wm iface equals make a channel, right? If it's not okay, we need to make it. We need to make the slice in the first place, right? So we need to make the slice of channels. No, actually we don't anymore, because this is just a slice top level type. So wm iface changes. This goes away. This goes away. I think this can go away too. Because now this is a map. We add an entry into the map. The map is already allocated. And then we append the channels that are listening for interface changes for this event to here. So this change channel now needs to be a channel of event. That simplifies things nicely. We remove a layer of indirection because we no longer have the concept of changes. So notify is a function that will receive an event for... So notify will now receive an event instead of a change set. For each interface in the map, we need to check the channels that are registered and then send on each channel. So there's no longer the concept of interest here. We now need to, let's see. I apologize for being quiet. I'm just like trying to think through this and trying to refactor this code in a way that makes sense. Thankfully, we can simplify a lot of it, which is pretty nice. For each interface, well, we need to attach the interface. I guess we might need to, actually. So, for the interface and for the subscribers... Notify colors. Yep. This is a slice of channels. So for, oh no, we've already got it. Okay. Subscribers. For each subscriber, you get a channel, and on the channel, you send the event. Range change? No. WM. So we iterate over the map. And then we're going to specify, we're going to add the interface to each of the events as well, I think. Because this layer will probably know about the interface, but we don't necessarily want to make that fish it out. So we have it at this level, we should probably specify it as well. So maybe instead of an event being returned, this would be the sys thing, like the empty interface. We'll see. Anyway, so events.interface equals iface. Right? Oh, this isn't quite right yet. So the event is only going to pertain to a single interface. So we want to look up that interface and get its subscribers. We don't want to iterate over all of them. So what we actually want is... So the event has to know about it. Okay, so subscribers, okay, colon equals WM, the events interface. So if there is nobody listening, we do nothing. Otherwise, we do this. I think this is what we want. So now, when this notify callback is fired with an event, we look for callers who are listening for events for this interface. If there are none, we do nothing. But if there are some, we iterate over them and send on the channel. I think that's right. Okay. I think we've mostly fixed this file. So for the time being, this entire concept of changes is going to go away. We're going to have to fix the other platform code too. Let's look at the Linux code. Okay. So now we have this concept of an event. So notify is a function which has an event. So RTM group link. I'm pretty sure this is actually in Exis already. So let's check RTM group link. It is. Sweet. RTM group. And we're also going to want IPv6 interface addresses as well. So maybe we'll leave it up to the caller for those. This is where things get tricky. This abstraction is going to be weird because in our case, we only care about v6 and the link. We don't care about v4 at all. But RTM group link. And we'll subscribe to v6 addresses for now as well because this code is internal to the package and we're not open sourcing it again for the time being. So we want link changes and v6 address changes because those are what we care about. Yep. This code still works as far as cancellation and reading messages. And then for every message we receive now, we no longer process it. We don't produce a change set anymore. This all goes away. We actually pass it back up directly because the caller will know what they want to do with it. So, I can actually wipe a lot of this out. Actually, I think we're going to need to inspect the messages a little bit to get the interface name, but so given messages, produce, and event, right? Yeah. Event. So return E. So for link messages, we need to check the attribute's name. This is the interface. So e.interface equals m attribute's name. Yep, perfect. And then e.sys would equal the entire slice of messages. So we have to inspect the first message in a group, I think. I don't think we'd actually care about the other ones, because they would, in theory, all have the same information. But so let's take a look at this really quick. So if len messages equals 0, I don't think that can actually happen. I think it'd have to be at least 1. So let's just look at the first one for now. So m colon equals messages 0. So now remove the loop. I'm not sure m attributes can be nil, actually. So let's do this. So now we get link messages. We're also going to want to add a case in here for the other types because we want to inspect the other ones. So log printf percent number v percent t percent number v, right? And we want to return. So the event contains all of the route net link messages for this event. Messages. Okay. This is going to be pretty interesting. Let's see if this even builds. It's been a while. What package do I need to look at? CoreRAD, I believe. Go build. Yes. So now lots of things will need to change. So fun. Advertise. Okay. Let's look at that. 91. This is a channel of netstate events now. Yes. Actually, I guess I could just do search and replace, couldn't I? So find dot netstate.change, replace with netstate event. Okay, there we go. That picks up a lot of those. Server 120. So now we subscribe to all the changes for a given interface. This interface's events. So the listeners can react accordingly. Okay. Well, it builds. I'm guessing it doesn't do anything useful yet, but let's check the tests. Link down, yeah. I actually have a test here that like will make a change and everything. Right? Oh, we just produced a message on the channel. Yeah, I think this is, we can cheat this a little bit. Netstate event. The contents of the event don't actually matter. Okay, the test passed. That's promising. Let's just see what in the heck this even does. I suspect this is going to be pretty bad, but let's set the development scripts, and then we're going to see what we can do. Okay, build it, run it, sudo right. So now it's going to watch for link state changes. So if I set one of these links down, set down CoreRAD Vitho. Okay, we got some messages in there. It is currently retrying initialization. If we set it back up, I would expect it to react in kind as well. I think this is broken. Oh, I upped one, didn't I? There we go. Oh, it worked. Sweet. It worked flawlessly, apparently. That's a surprise. Anyway, let me analyze this really quick. So the messages we got here, we got route netlink address messages. Oh, so we got address messages in addition to the other ones, I'm sure. So how many events is this? Does this give me a whole bunch of events probably? I think we'd have to debounce this, unfortunately, which stinks, but I wonder if I should do the debouncing in this library itself, or if I should do it in the caller, and probably the caller, but huh. This is gonna be kind of silly, but oh, hang on a sec. Let's see the address messages as well, since we're listening for those now. Let's see if we can add those pretty easily to this code. Cornelia Vesa, thank you so much for the follow. Does this have the interface name attached as well? I'd imagine it probably does. Family, prefix, created, updated, index. Has the interface index. Okay, we can work with that, I think. That means we're going to need to do a lookup. I guess that's probably fine. I bet the other one has the interface index as well, actually, so yeah, getting down a rabbit hole a bit. All right, I am out of water. I'll be right back. All right, we're back. So maybe we should work on interface indexing this whole thing. I think that might actually be easier, at least for Linux. So we're going to need to look up the interface name, interface by name, and then pass in the keep track of the index as well. So let's see here. How can we do that? So we already have route netlink sockets open down here. We can in theory just query for it, but I guess I'd rather not do queries on demand. Maybe, I don't know. Maybe we'll do it up here in the higher level code instead. But I guess then we'd have to return like probably an error here, but I guess that's probably fine. I mean, it's a little more verbose, but it's not that big of a deal. So subscribe, error. Net interface by name, error. Right. So now the watcher will keep track of the... Is that going to work? Nah, yes? Yes, it will, I think. Actually, hang on a sec. We might have to plumb in OS watch as a method now instead, so we can keep track of some of the data from the map. But, all right, one sec. So we're going to be watching interfaces, and each interface can be keyed by its name and its index. Perhaps the index would be useful too. Index int, name string, something like that. So we get the interface index and the interface name, and then the sys information about it as well. So, So now we want to figure out how to get that information plumbed from up here down here. So I think it probably makes sense to have a map of this information and then be able to look it up by index or by name. I think by index is probably going to be easier actually. So let me just check really quick. I'm pretty sure this route netlink link message. Actually, we can just look at the definition, can't we? As the interface index. Awesome. Okay, so we can just key by the index then. So we'll do that. Just to make things easy, we'll key by the interface index internally. Although externally, I think that the interface name is probably easier. But we can key by index. So we need to lock the same mutex. I guess probably we would. Yeah. So by index map int string, yeah, because then we could put in the interface index and everything as well. So this will let us know, this will let us tell us which kind of event we need to generate for a caller who is interested. So I think in this case what we want to do now is OS watch. Let's see here. W watcher. So OS watch is now a method, so we have access to this map and this mutex. So this is a little weird, but W is a watcher. And then by default, watch using OS specific primitives. Yeah, so W watch equals W OS watch. Yeah. One of those weird things you can do because of pointers. Create a little loop here, you know. So make map string int to string. So this is going to be the interface index to the interface name. So the first time we get an interface, we need to actually look it up. We need to see if we already have an entry for it. I guess in this case, would we want a reverse index to save ourselves the lookups? Probably doesn't matter. We can leave it as an optimization. So to do allowed subscription, to do allow subscribing by index. And then in that case, we could use this directly. But anyway, so with that all done now, we will register it with the index. So W by index, so IFI index equals IFI name. Okay. So now we have this by index, and we can actually use this over here. So What did I do to server.go? Cancel. Oh, right. Excuse me. That's probably okay for now. This is going to return an error now. Does this function return an error? Yes, it does. Okay. Failed to subscribe to %q changes %v. iface name, error, done. Perfect. Right. Huh. So we're coming up in about 2.5 hours, a little more than that. I think we'll probably wrap up the next like half hour or so. Bit of a, like 3-hour-ish stream today. It seems pretty good. I probably won't be back until Friday. I think I'll probably stream during the day on Friday at some point. We will see. But I'm going to take tomorrow off. Need some time away from coding, So now that we have this, whenever we're processing an event, we can actually access that same map. We can look it up right here if we wanted to, actually. So we need... I guess we don't really need this process function as much anymore, but maybe W process? Yeah, so we can still access the map. Okay. So we'll create an event, and then we look at these route netlink messages, and we see where the interface index is, and then use that to infer the rest of the information for the event. So if it's a link message, it will have, in addition to the attribute's name, which is cool, but we don't actually care about it anymore because now we're looking it up externally, we can gather the index from here. So eindex, the index of the event is going to be the m index from the message. Likewise, the address message has the same thing. Address message. Yep, they both have an index field. And when that lookup is done, we can now infer the interface name as well. So w mu rlock. W mu runlock. E.name equals w by index e index. There we go. Okay, so now we should be producing events that have the interface name, the interface index, as well as the changes, the route netlink messages, which is great. So that's good. We'll remove it from the logging. Well, I guess we'd still want to know if we get a type that we don't expect. I think we're only going to have addresses and links for now, but we'd want to know if there's anything else as well. So, events name, right? This is all keyed by name at the moment. Anybody who's listening. Right. Okay, I think we're back to the server code now. So we want the, where is this live? Is it listener, actually? I want the link state watcher. Where is it? I think it's in server, actually, now. I think I moved it around just recently. Yeah, right here. So, given a change, we want to iterate over it and see what all is in here. Event on w index. I guess we'll call it E now for E for event. E index, E name. And then we will iterate over the messages in sys. This is going to be gross. We're going to do a type assertion right now. And we're going to factor this out into some OS dependent code, like probably the system package or something. But for the time being, we're still prototyping this idea. So I think this is probably going to be, it'll be fine, So for M, so for each netlink message, this is going to be esys is a slice of route netlink messages. Yep. Log.printf m%t%v m. Okay, so now we should get a whole bunch of events pop up whenever we get something triggered by the system watcher, which is good. So let's go back over here, build, Enough arguments to return. Line 82. Okay. Sure, you got me there. IU96, thank you for the follow. I appreciate it. And no. Yep. Okay. Sudo do it. And let's drop the link. Sudo IP link set down. And what we should see here is a bunch of route netlink messages being printed out. Yes, excellent. So we got an event there for and up. Okay, perfect. So what we saw was a route netlink link message for veth0 and also veth1. And it's interesting. I think we got that for veth1 because it's a veth pair. So the state for both of them changed. So this is where we can examine the events looking for things like state up and down. And then it retried. We got another event, which is the address message. Huh. So if I take this down, I apologize for the small text. Let me make that bigger for you all. The problem is it's just a lot of information on the screen, so I'm trying to keep it less verbose, but... So if we set this link down, we get a couple of link messages, okay? So if we start it now, it will keep trying to initialize because the link is not ready. And if I set it back up, then we get a few re-inits here. So we're going to have to demount this. So we're getting, oh, let's see here. Anything that says event. So veth1 comes up, veth2, or veth0. We get a link message, we get an address message. So this is when the IPv6 address is being assigned to the link, I think. Yeah. We're going to have to pick this apart. Okay. Well, I think this is probably a good place to checkpoint this for today. I'm just going to put it in a branch probably. This is something I want to rework, but the problem is that I've got everything working pretty well other than this right now. So I think I'd like to do another release so I can start running the newer stuff at home. So let's checkpoint this really quick. Looks like I can pass the context function to dialer or snag the FD that way. Yeah, I think so. I think that would do it. I don't get the context itself, but I can just query to see if the FD still exists. Yeah, I would be careful. I would be careful with like pulling the file descriptor out of there. Like, yeah, you'd have to. You might consider like wrapping the netcon or something so that like you know like when it gets closed or something. Because if you pull the file descriptor out of there, then things could get tricky. When I guess you probably get like ebadfd from the syscall, so maybe it's not that big of a deal. But anyway, I'm gonna put this in a work in progress branch. Yeah, work in progress, net state. Work in progress. Excellent. So what we have on master right now should work pretty well. Run it. Okay. Set the link down. Keeps trying to reinitialize. Set it up. It comes back. Same thing. And veth1 as well, the exact same thing. So this package is pretty resilient to like link state changes. Like it works pretty well, but I think it could be smarter and do things in a faster way with more information, which is why we're making these net state changes. So, excellent. Okay, I think we're probably. This is in good shape. Let's verify the CI build just in case. We probably haven't looked at this in a while. Let's see. Yeah, let's close a bunch of these tabs. Is my build passing? That's always a good question, right? Yep, it's passing. Okay, cool. Let's tag a release. Let's do it. I definitely want to get Debian packages going for this too, in case folks want to run this in their Debian systems. I run it on NixOS, so that's just easier for me. Yeah, so what is it? Git tag, yep, 026, I think. Yes, 026. And pretty soon I will start doing a changelog and everything as well. Probably with 0 to 3.0. I think we're coming up on that point pretty soon. So let's do a tag, get push tags. Excellent, excellent. And now we can add this to NixOS. All kinds of fun. So we'll log into my server for that because my server runs NixOS. Let's see. Do we want to do the SSHFS? Nah, we can probably just do it with Nano. It'll be fine. So, source Nix packages status. Okay. So we're going to add this. No. Okay. Eval. Yeah. There we go. Excellent. So now we can pull the latest copy of this. This repo has tons and tons and tons of changes. And we're going to put this in so we can use this on NixOS, which would be cool. So prefetch, yeah, right. So MD layer CoreRAD archive v026. And this gives me a checksum I have to put into the NixOS build file. So nano packages, tools, networking, CoreRAD. There we go. So now we are putting 026 in the repo. The SHA-256 of the thing is this. We have to actually build this as well, so that is how we figure out the Go modules derivation. It's kind of silly, but... Oh, and I need the new link timestamp as well, so I'll have to get that. So, what's that? Git rev parse shorthead? No. Git log. There we go. So with this git log command, I can actually query the timestamp in Unix time for when the binary was built. So perfect. I want to automate this and get it to fetch from the NixOS stuff. I just have not done that yet. So in the meantime, we just update the link timestamp manually, which is annoying, but it works. 025, 026. Excellent. Okay. Now we need to try building this. And once we do that, we can see what works. So source Nix packages. Save the file, and then what do I do here? Oh, Nix build -a. Yep. Thankfully, my server is a lot faster at building Nix packages than my my router. So, oops, that's the wrong way. There we go. So this is pulling the repo. It's going to do all the Go module stuff. There we go. So you can't quite see that message. There we go. So it expected a different Go modules hash. It actually does a checksum of all of the dependencies, like takes a hash of the whole thing. So I need to put this in the file. I don't know a way to pre-compute this other than just running the build. It's kind of annoying, but it is what it is. So with that up to date, this should now build just fine. So this is how you get a Go thing built on NixOS. All right, we have produced a binary now. So if we go to result bin, I shouldn't have cleared that. That's okay. We can copy and paste it from the scroll back. CoreRAD -h. There we go. 026 beta. Pretty cool. Built today. Awesome. 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 So we're gonna open a pull request. Nix packages. We're gonna copy an old one I did because I can never remember all the stuff I like to include. So author me closed. And by doing this, I'm going to be able to promote this on my router, which is why I am doing this. So we're going to need to create a new pull request. So I'll use a new window here. One sec. I guess we can use this one for reference, and we can use the other one for actual commits. One sec. I can't create another guest thing? Oh, that's sad. Okay. Anyway, we can flip back and forth. That's not a big deal. So... git diff. Yep. Packages. Commit-m. What's the syntax here? CoreRAD 024. Okay, so CoreRAD 025 to 026. Perfect. I think I just committed on my master of my fork, didn't I? It's annoying. Okay, branch-m, mdl, CoreRAD, bump. Okay, and push-u fork head. This will create a branch that I can use to create a pull request. There we go. So basically what I do here is I explain what I've done. New beta release of CoreRAD. We tested it, so we actually built the binary on NixOS, and we tested that it actually executes, so that's good. We didn't actually modify it in the test in this case. Yes, we verified the execution of the binary files, and it does fit contributing, because we've done that before as well. So I'm going to copy and paste exactly what I did before. So built and tested, yeah. Built and tested on NixOS. Oops. This is where we grab some of the terminal outputs so they can actually verify that what we did is legitimate. Right. 026. Yep. And now I'm going to scroll up a little bit and grab some of the other outputs so we can verify. There we go. I like to abbreviate the build output a little bit so it's not too messy for folks. And then just the very last bits, basically. So, like, something like that. That's fine. So now we have all the info we could need, and I think we just tag a couple of the maintainers. So I'm the maintainer of this package, but I also tag a couple of other folks who generally review my PRs. So these two, I believe cow is done. There we go. (026) new hash, new vendor, new timestamp. Awesome. We did it. So now we create the pull request, and when this gets merged, I update my NixOS unstable channel, and the binary will update automatically. So that'll be easy enough. Very cool. So I think with that, we're kind of up in about 3 hours, and I'm getting kind of tired and stuff. Thank you all for hanging out. It's been a lot of fun. Does anybody have any questions? Any questions, things you'd like to see, etc.? Otherwise, I guess we'll find somebody to host and raid. See what we can do. Is anybody streaming programming? No, not at the moment. Oh, let's see here. Ah, that's not what I wanted. Oh yeah, any questions? Not seen anything so far. So, yeah, cool. Thank you all so much for hanging out. This has been a blast. I guess today doesn't look like anybody's really streaming programming or anything, so I guess we'll just call it there. Thank you all so much for hanging out. If you are interested, please feel free to contact me. Reach out on Twitter. Go for Slack. I also just created CoreRAD on IRC as well. So on Freenode, if you go to, where is it? Yeah, see you later. So if you go to CoreRAD on Go for Slack or Freenode, we also have that channel now as well. Feel free to join. If you'd like to give this a try, I would be happy to show you a few things. I have my dashboard published at the moment. I will be publishing my alerts. I think this is in good shape. I'm pretty sure we're going to tag like a 03x soon, you know, basically like a 1.0 release candidate sort of thing. Yeah. Feels good. So, all right. And with that, I will see you all later. Take care.